Hi and welcome to this ADF Academy presented by Consist. My name is Christian and today I'm going to show you how we can do a commissioning without load installed. So how we can go through the diagnostic without the need of CTs. We are right now in a system setup where we have already checked through all of the data that fits here. And we have a 200 amp CT. However, this 200 amp CT has at the moment no load. It is in closed loop, so this only works in closed loop operation, but we have it here in closed loop, so we can go ahead and run the diagnostic. During the diagnostic, the ADF is trying to figure out what is going on the grid to see if all the load is there and all the measurements can be taken. And right now you see we get information that detecting the CT current was failing. What we require is about 4% of the CT ratio, so 4% of the 200 amps to be able to identify the CTs. We don't have that right now. We have zero load. So we have a button here to override all the CT checks. I will be able to do that right now. And with that overwriting, I can do a new diagnostic and run the entire diagnostic, but this time without checking the CTs. The diagnostic ended successful. All these tests have been done except the tests with the CTs. They have been skipped. So we know the filter itself works. However, we don't know the situation of the CT. To be able to figure out how if the CTs are correctly installed, we can use reactive power. So if we are going into the normal operation mode of the filter and we're going to the compensation settings, I'm gonna start the active filter at this point and I'm gonna put some static reactive power out. If we just put out a smaller value, 20 kVAR, save that value, then we should see the CTs. And what we can see already now on the CTs is that at least the phase 2 is inverted. The other phases, it's not quite clear. It might be correct, but at least phase 2 is clearly inverted here. So what we need to do is we need to invert the phase 2. If we have done that, we will see if the rest is fine. Now we can see that the rotation of the CTs is at least correct. What we don't know for sure right now is if the CTs is on the correct direction. So we have only reactive power, and we can see here we see capacitive reactive power. However, we injected inductive reactive power. So we shouldn't see a capacitive reactive power, which we do see here. If I change that and change it to a capacitive reactive power, now it changed over to inductive. So there's clearly something wrong. Seems like all the CTs are inverted as well. So we can fix that very quickly in the system setup. I can just say invert all the CTs, run a new diagnostic. The diagnostic will again take about 10 seconds to run. And after that, we can do the test one more time. Here we go. The diagnostic is finished, so we can restart the system one more time and we can get back to the testing. We go back into the compensation setting. We start with 0 reactive power, save that and start the active filter. What we see right now is only the capacitor of the LCL filter, and we see some capacitive reactive power of about 1.5 kVAR. And we're seeing it as capacitive, which is the right direction. If we now go back here and we add 20 kVAR capacitive, we should see this one increasing to about 21 kVAR. You see that jumping up to 21 kVAR, exactly what we expected. And if we're doing the minus 20 kVAR or inductive reactive power, then we should see that going down to about 19 kmol, 18 kmol. Pretty good. So now we know that first of all the amplitude of the CTs is correct, but we also know that the phase order and the phase direction of these CTs are correct. So we just verified the entire CT setup of the filter, and we can start the filter and operate with the filter now. That is all for today. Thank you so much for watching and see you next time.